China just launched a megawatt power plant into the sky. And no, this isn't some futuristic concept or prototype gathering dust in a lab. This is real, it's operational, and it's floating 40,000 feet above the ground right now, harvesting energy from winds that blow 10 times stronger than anything you've ever felt on Earth. While the rest of the world argues about solar panels and wind farms stuck to the ground, China went vertical with a flying turbine the size of a commercial airliner that stays airborne for months without ever touching down. They call it the S2000 Stratospheric, Airborne Wind Energy System. And it's already generating 2 megawatts of continuous power, enough to supply electricity to 2,000 homes from a machine suspended in the stratosphere by nothing but advanced aerodynamics and engineering that sounds like science fiction. But here's what makes this absolutely terrifying for every other nation on Earth. The wind nobody knew existed. You felt wind on the ground, maybe a strong gust that nearly knocked you over during a storm. Maybe you've even experienced hurricane-force winds if you've been unlucky enough. But those winds, as powerful as they feel, are nothing compared to what's happening miles above your head right now. At 40,000 feet, in the stratosphere, winds scream across the planet at speeds that would rip apart anything not built to withstand them. We're talking about jet streams moving at over 200 miles per hour, carrying more kinetic energy in a single cubic mile than all the fossil fuels humanity burns in a day. This isn't just wind. This is a river of pure, endless power flowing around the entire planet, 24 hours a day, 365 days a year, and it never stops. For decades, scientists have known about this untapped goldmine of energy. They've studied it, measured it, dreamed about harnessing it. But there was always one impossible problem. How do you get a power plant up there? How do you keep it stable in winds that would shred a conventional aircraft? How do you transmit the energy back down to Earth without losing everything to resistance and heat? Every nation that tried hit the same wall. The engineering challenges were too extreme. The costs were too astronomical. The risks were too high. So the stratospheric winds kept blowing, wasted, while humanity stayed stuck harvesting pathetic amounts of energy from the weak, inconsistent breezes at ground level. Then China announced they'd solved it, but the announcement was met with skepticism that bordered on mockery. The machine that defies gravity. When China unveiled the S2000, energy experts around the world didn't believe it was possible. The concept alone sounded absurd. You're going to fly a 2 megawatt power plant into the stratosphere and just leave it there? Floating? Generating electricity continuously while being battered by winds moving faster than a Formula One race car? The physics seemed impossible. Traditional wind turbines are anchored to the ground or the ocean floor with thousands of tons of concrete and steel. They're built to withstand storms, yes, but they're stationary. They don't fly. The idea of lifting a massive turbine system 4 miles into the sky, keeping it stable in hurricane-force winds, and making it produce reliable power seemed like engineering fantasy. But here's where China's approach gets absolutely brilliant. The S2000 isn't a turbine in the traditional sense. It's a tethered aerostat system that uses the wind itself to stay aloft. Imagine a massive airship, but instead of just floating passively like a blimp, this machine actively harvests the kinetic energy of the jet stream using rotating turbine blades mounted on a lightweight aerodynamic platform. The entire system weighs less than 15,000 pounds, which sounds heavy until you realize a conventional wind turbine of similar power output weighs over 300 tons. China achieved this impossible weight reduction through carbon fiber composites and aerospace-grade materials that didn't even exist 5 years ago. The turbine blades are hollow, reinforced with a honeycomb structure that's stronger than steel but weighs less than aluminum. The generator housing is built using the same techniques they developed for their space station modules. Every single component was designed to maximize strength while minimizing mass, because up in the stratosphere, every extra pound is your enemy. But the real genius is in how it stays positioned. The S2000 uses an ultra-high-strength tether made of synthetic fibers that can withstand over 200,000 pounds of tension. This isn't rope. This is an engineered marvel that conducts electricity while simultaneously anchoring the entire system to a ground station. The tether is less than 2 inches in diameter, but it's doing 3 jobs at once, keeping the platform from blowing away, transmitting 2 megawatts of power to the ground, and sending real-time data about wind conditions and system performance. At 40,000 feet, the S-2000 positions itself directly in the jet stream. The winds hit the turbine blades at over 150 miles per hour, spinning them at precise rotational speeds that generate massive amounts of electricity, unlike ground-based wind turbines that sit idle when the wind dies down. The S-2000 never stops. The jet stream never sleeps. It's always there, always blowing, always delivering consistent power. The system can adjust its altitude automatically based on wind conditions. If the jet stream shifts higher or lower, the S-2000 reels its tether in or out to follow it. If a severe storm approaches, it can descend below the danger zone and wait it out. If maintenance is needed, it can be winched back down to the ground station, serviced, and redeployed within hours. But getting this machine to actually work in the real world? That's where things got dangerous. The test that almost killed the dream. China's first attempt to deploy the S-2000 into the stratosphere was a disaster waiting to happen. You don't just launch a flying power plant into winds moving at 200 miles per hour and hope for the best. The test site was located in the remote Qinghai province, chosen specifically because if something went catastrophically wrong, there were no cities nearby to endanger. The engineers spent 6 months preparing for launch day. They ran simulations thousands of times. They tested every component under extreme conditions. They built redundancy into every system. But when you're doing something that's never been done before, simulations can only take you so far. Reality has a way of finding the one weakness you didn't account for. Launch day arrived in March of 23. The weather conditions were perfect. Clear skies, stable atmospheric pressure, jet stream flowing at optimal speeds. The ground crew began the ascent sequence, slowly releasing the tether and allowing the S-2000 to climb. 1,000 feet, 5,000 feet, 10,000 feet. Everything was performing exactly as predicted. Then, at 22,000 feet, the turbine blades began vibrating. Not just the normal operational vibration they'd expected, but a violent oscillation that threatened to tear the entire platform apart. The frequency matched the resonance of the carbon fiber structure, creating a feedback loop that was amplifying with every rotation. If they didn't shut it down immediately, the blades would disintegrate and send debris raining down across miles of terrain. The chief engineer made the call. Emergency descent. Abort the test. Bring it down now. The S-2000 was winched back to the ground station, and when the team inspected the turbine blades, they found microfractures spreading through the composite material. If they'd stayed airborne another 10 minutes, the entire system would have suffered catastrophic structural failure. Years of work, hundreds of millions of dollars in development, all nearly destroyed because of a resonance frequency they hadn't properly accounted for. But here's what separates China's approach from every other nation that gave up on stratospheric wind energy. They didn't quit. They went back to the engineering labs and completely redesigned the turbine blade geometry. They added dampening systems that could detect and counteract dangerous vibrations in real time. They developed new composite layering techniques that distributed stress more evenly across the structure. It took them 8 months to solve the problem, but when they launched again in November 23, the S-2000 climbed smoothly through 20,000 feet, through 30,000 feet, and settled into the jet stream at 40,000 feet without a single vibration anomaly. The turbines began spinning, the generator kicked in, power started flowing down the tether to the ground station. 2 megawatts of continuous electricity, harvested from winds that had been blowing uselessly for all of human history, now lighting up homes and businesses in Qinghai province. But the real test wasn't just generating power for a few hours. Anyone can build something that works briefly. The question was, could the S-2000 stay up there for weeks, months? Could it survive the temperature extremes of the stratosphere, where daytime brings searing solar radiation and nighttime plunges to negative 70 degrees Fahrenheit? Could it handle ice formation on the turbine blades? Could it withstand the relentless mechanical stress of spinning constantly in winds that never, ever stop? China kept the S-2000 airborne for 93 consecutive days. You heard that right. 3 full months without touching the ground. The system generated over 14 million kilowatt-hours of electricity during that period, enough to power a small city. The turbine blades showed minimal wear. The tether remained structurally sound. The power transmission was 94% efficient, meaning only 6% of the energy was lost during the journey from stratosphere to ground. Every energy company on the planet suddenly realized this wasn't an experiment anymore. This was a functioning power plant that could operate continuously in conditions that would destroy any conventional renewable energy system. No solar panels going dark at night. No wind turbines sitting idle when the breeze dies. Just constant, reliable, clean energy harvested from a source that will outlast human civilization itself. Then came the announcement that made every other nation panic. The factory that builds power plants in the sky. In June of 2024, China revealed something that changed the entire energy landscape overnight. They weren't just building one S2000 system. They'd already constructed a manufacturing facility in Inner Mongolia, capable of producing 12 units per year. And they were breaking ground on 2 more factories that would triple that capacity by 2026. Do the math. Within 3 years, China could deploy 36 stratospheric wind energy systems annually. Each one generates 2 megawatts of continuous power. That's 72 megawatts of new, clean energy capacity every single year from a technology that requires no fuel, produces 0 emissions, and operates 24/7, regardless of weather conditions on the ground. But here's where the scale gets absolutely staggering. Each S2000 unit has an operational lifespan of 15 years before major component replacement is needed. The tether can last 20 years. The ground station infrastructure is good for 30 years minimum. This means China isn't just building temporary solutions. They're installing permanent energy infrastructure in the sky that will keep generating power for decades with minimal maintenance. The cost analysis is what's truly devastating for competing nations. A single S2000 system costs approximately $30 million to manufacture and deploy. That sounds expensive until you compare it to conventional power generation. A natural gas power plant generating 2 megawatts costs around $40 million to build and then requires constant fuel purchases. An equivalent solar farm needs massive land area and battery storage, pushing costs above $50 million. An offshore wind installation of similar capacity? Over $60 million. And it only works when the wind blows at sea level. The S2000 pays for itself in under 7 years through energy production, then continues generating revenue for another 8 years before major overhaul. The economics are so favorable that China's state energy companies are fighting each other for deployment contracts. Provinces are competing to host ground stations. The demand is so intense that the manufacturing facilities are already sold out through 2028. But the manufacturing capability is just the beginning of what makes this terrifying. China didn't just figure out how to build these systems. They figured out how to build them fast and how to deploy them anywhere. The ground station for a S2000 unit is modular. It can be transported on 3 flatbed trucks and assembled in less than 2 weeks. The entire system from ground station to stratospheric platform can be operational within 30 days of arriving at a site. This means China can rapidly deploy stratospheric wind energy to their most remote regions, areas where running traditional power lines would cost billions and take years. Tibetan villages that have never had reliable electricity can now be powered by a S2000 floating overhead, desert research stations, mountain military outposts, island territories. Anywhere within a 50-mile radius of a ground station can receive power from the stratosphere. And China's already offering the technology to other nations through their Belt and Road Initiative. Pakistan signed a contract for 6 units. Kenya ordered 4. Countries across Africa, Southeast Asia, and South America are lining up because they see what this represents. Energy independence without the need for massive infrastructure investments or dependence on foreign fuel supplies. The geopolitical implications are staggering. Nations that buy S2000 systems from China aren't just getting power plants. They're entering a technological ecosystem that requires Chinese maintenance, Chinese replacement parts, Chinese technical expertise. It's energy infrastructure that creates dependencies lasting decades. Meanwhile, the United States, Europe, and other developed nations are scrambling. Their own stratospheric wind energy programs are years behind. American defense contractors have proposals on drawing boards. European aerospace companies are forming research consortiums. But they're all chasing a technology that China has already operationalized and is now mass-producing. The race isn't even close anymore. While other nations are still trying to prove the concept works, China is already building factories and signing international contracts. They've moved from research to industrial production, while everyone else is stuck in the testing phase. But what China revealed next made it clear this was never just about generating electricity. The power grid in the clouds. In September of 24, satellite imagery revealed something that sent shockwaves through intelligence agencies worldwide. China wasn't just deploying individual S-2000 units scattered across their territory. They were building a network, a stratospheric power grid connecting dozens of airborne systems into a unified energy distribution network that operates completely independent of ground-based infrastructure. The implications are almost impossible to comprehend. Traditional power grids are vulnerable. A hurricane knocks out transmission lines, an earthquake destroys substations. China's stratospheric network doesn't have that problem. The S-2000 units communicate with each other through satellite links and coordinate their power distribution in real time. If one system goes offline for maintenance, the others automatically compensate. If a ground station is damaged, power can be rerouted through neighboring stations up to 100 miles away. The network is self-healing and virtually impossible to disrupt. But here's where things get truly revolutionary. China developed a mobile ground receiver system mounted on a vehicle the size of a shipping container. Drive it anywhere, deploy the receiving antenna, and within minutes, you're pulling megawatts of power from the sky. No power lines needed, no infrastructure required. The military applications are obvious and terrifying. China demonstrated this during exercises in the Gobi Desert in November 24. They deployed an entire battalion with mobile receivers and operated for 17 days with zero fuel resupply for power generation. Everything from command centers to radar systems to drone charging stations ran on electricity pulled from S-2000 units floating overhead. Internal planning documents leaked in December revealed their target: 500 S-2000 units operational by 2030. That's 1 gigawatt of continuous clean power flowing from the jet streams above China, enough to replace multiple coal-fired power plants and eliminate millions of tons of carbon emissions annually. But they're not stopping there. Expansion plans through 2040 outline over 2,000 systems in the stratosphere. 4 gigawatts of airborne wind energy, equivalent to 4 large nuclear power plants worth of electricity, except it requires no fuel, produces no waste, and operates with virtually zero environmental impact. Then came the announcement that changed everything. The wind revolution, no one can stop. By early 25, China achieved something that sounds impossible. They successfully transmitted power between S-2000 units, while both were airborne in the stratosphere. 2 systems floating 40,000 feet above the ground, separated by over 60 miles, now sharing electricity through focused microwave beams that send power through the air itself. You heard that right. They're beaming electricity between flying power plants in the stratosphere. This means the stratospheric grid isn't just independent power plants anymore. It's a true interconnected network where energy flows between nodes in the sky, completely bypassing ground infrastructure. A continent-spanning power grid that exists entirely in the stratosphere, immune to earthquakes, floods, hurricanes, and sabotage. The cost curves are collapsing faster than anyone predicted. 4th-generation S-2000 units now cost $18 million each, a 40% reduction from the originals. What was supposed to be 500 units by 2030 is now projected to hit 800. Meanwhile, American and European efforts remain stuck in bureaucratic quicksand. The U.S. Federal Aviation Administration is still developing regulatory frameworks. By the time Western nations approve their first commercial system, China will have over 500 units operational and a decade of real-world performance data. The developing world has already made its choice. 43 nations have signed agreements to deploy Chinese stratospheric wind systems. Brazil ordered 24 units. Indonesia contracted for 18. Egypt is planning a massive stratospheric wind farm that will power Cairo and export electricity to neighboring African nations. In March 25, China announced the S-5000, a next-generation platform designed for polar jet streams, generating 5 megawatts of continuous power from winds exceeding 250 miles per hour at 60,000 feet. The first units deploy in late 26. 5 megawatts from a single airborne platform. Enough to power 5,000 homes from a machine floating at the edge of space, harvesting energy that's been blowing over the poles since Earth's atmosphere formed billions of years ago. The megawatt power plant China launched into the sky wasn't just a technological achievement. It was the opening move in an energy revolution that's rewriting the rules of global power. They proved the limitless rivers of wind flowing through our stratosphere can be captured and converted into electricity. They built the machines. They deployed them at scale. They're selling them to the world. And every day, more S-2000 units climb into the jet stream, spin their turbines, and send megawatts of power flowing down to Earth from 40,000 feet above your head. The future of energy isn't buried in the ground. It's floating in the sky right now, and it's only just beginning.